Problem number 39. The angular momentum of a flywheel having a rotational inertia of 0.14 kilogram meter square about its center axis decreases from 3 to 0.8 kilogram meter square per second in 1.5 seconds. So we have a flywheel, and this flywheel have the rotational inertia I, which is nothing but 0.14. And what happened here? Its value decreases. That means its angular momentum value decreases. So initial value of the angular momentum is 3, and then the final value of the angular momentum is 0.8. And so this decreasing value will take place at a time interval of 1.5 seconds. So these three informations are given. What are the three information? They gave the initial value of the angular momentum, which is 3, and the final angular momentum LF value, which is nothing but 0.8, and the time interval is given here as 1.5 seconds. By using these three information, we have to find the answer for this four questions. So let's read the first question. What is given in the first question? In the first question, we have to find what is the magnitude of the average torque acting on a flywheel about its central axis during this period. That means we have to find the value of torque tau. That means average torque. What is the formula for average torque? Which is nothing but the change in angular momentum divided by change in time. That's the formula we studied in chapter number 11 in the theory class, right? So I have to use that formula. And then the second question, assuming a constant angular acceleration, through what angle does the flywheel turn? That means we have to find the answer for theta. So by using the three main equation, we have to find the answer for the theta here. And then third question, we have to find how much work is done on the wheel. And finally, we have to find what is the average power of the flywheel. So first of all, let's rewrite the given first. So what is given in this question? In this question, they gave the moment of inertia. That means the rotational inertia's value is given, which is I equal to 0.140 kilogram meter square. And then initial angular momentum Li value is given, which is 3 kilogram meter square per second. And then the final angular momentum value is given, which is 0.8 kilogram meter square per second. And then the time interval delta t or t, you can just write, which is 1.5 seconds. So in the first question, we have to find the answer for the average torque. So let's rewrite the rule for average torque. So average torque tau, which is equal to delta L over delta T. So what is delta L? LF minus Li divided by delta T, which is nothing but TF minus TI, but they gave the value directly as 1.5. So now I'm going to substitute the value. So what is our value for LF, which is 0.8, and then Li value is 3 divided by 1.5. So let's see the answer. So here I got the answer for the average torque, which is equal to 1.466 I got. So I can write 1.47, and the most important thing, the sign is negative here because you can see the value, the final value is small, initial value is greater. So here we got the answer as negative. So minus 1.47 Newton meter, which is the unit for the torque. But you can read the question here. They ask you to give the magnitude value. So that means magnitude, we can just take the positive value. So therefore, the average torque magnitude, which is equal to 1.47 Newton meter. So this is the answer for the first part. Clear? And in the second part, we have to find the theta. How much turn does flywheel does the work in the time interval of 1.5 second. So we have to find the value of theta. So what we have to do, we have to use the second main equation, which is in terms of linear, what we studied, delta x, which is equal to v naught t plus half alpha t square. So this is half a t square, correct? This is our linear equation we studied in chapter number 2. If you convert these in terms of rotational, what we will get? We will get delta theta, which is equal to omega naught t plus half alpha t square, right? So this formula I am going to use. That means we have to find the value of theta, theta naught, theta minus theta naught, which is nothing but the delta theta. We have to find this value. So we use this equation and I am going to substitute. But the most important thing here, you can see there is no initial angular speed as well as the acceleration alpha is not given. So what we have to do, in place of omega naught, we have to use the rule of angular momentum. So L, which is equal to I omega. If you write these in terms of initial angular momentum, how we can write? Initial angular momentum Li, which is equal to omega I. So this better I can write initial as omega I. So what I am going to do, I am going to use this term to replace omega I. Therefore, omega I, which is equal to Li divided by I. Correct? So what I am going to do, I am going to take this term and I am going to substitute this formula here. And likewise for this alpha, I can use the Newton's second law form of rotation, right? So what we studied, which is torque tau, which is nothing but I multiply by alpha. So I am going to rearrange this equation in terms of alpha. Therefore, alpha, which is equal to torque tau divided by I. And what I'm going to do, I'm going to take this rule, I'm going to substitute here. So now once you substitute these two values, omega I as well as the alpha, then we can substitute the values for the value of initial angular momentum, rotational inertia, then we can easily find the answer for delta theta. So now what I'm going to do, let's we substitute this formula for omega I and alpha. So what we will get, delta theta, which is equal to, in place of omega I, what I have to do, I have to write Li divided by I multiplied by T plus half, in place of alpha I have to use torque tau divided by I multiplied by T square. Clear? Now let's we substitute the value. What is the value of the initial angular momentum? Which is 3, right? So 3 multiply time value is 1.5 divided by the angular momentum, rotational inertia, which is 0.14 plus half torque, because this time we have to use the real sign. So what is the actual value of the average torque, which is minus 1.47. So I have to use this value here. So let's we substitute the value here, minus 1.47 divided by 0.14, and the time is 1.5 square. So let's we find this value first. Let's see what will be the answer for this. 3 multiplied by 1.5 divided by 0.14, I got 32.14. So and then we have to find this here, minus 1.47 multiply 1.5 square divided by 2 multiplied by 0.14, I got minus 11.81, and then now I have to subtract this number with 32.14. So 32.14 minus 11.81, I got the answer as 20.33. 20.33, and the unit for rotation, which is angle theta, which is nothing but radian, right? So the unit for delta theta, which is nothing but 20.33 rad. This is the answer for second question, B part. And then third part, we have to find the work done. As we know the formula for work done. The formula for work done, W, which is equal to F multiplied by D, right? So here F is nothing but linear force D is the distance. So if you convert everything in terms of rotation, so F is nothing but tau, and D is nothing but, which is delta theta, which is theta, right? So now we have both values. So I'm going to substitute the value, which is torque takes the value of 1.47 multiply with 20.33. So 20.33 multiply with minus 1.47 minus 29.89 we got, and the unit for the work done, which is joules. So this is the answer for part C. And then finally we have to find what is the average power. So here, for finding the answer for average power, we know the power formula, power average, which is nothing but work done divided by time. But here you can see the work done by the wheel on the wheel. So it's very, very important. They clearly mention in the question. We can just go back to the question. You can see in the third part how much work is done on the wheel. If it is by the wheel, positive. On the wheel means negative. So what we have to do, you have to read the question very carefully. So in this place of work done, what I can do, I can just use the sign minus here. Why minus? Because work done by the wheel and work done on the wheel. By the wheel means positive, on the wheel means negative work done. So I have to use negative here. Now I'm going to substitute the value here. So for the work done, we got the answer here as minus 29.89. So minus of minus 29.89 divided by the time is 1.5 second, and minus into minus become plus. So 29.89 divided by 1.5, the answer I got as 19.93. 19.93, and the unit for power is watt. So this is the answer for the average power. Clear? So the most important thing in this question is like a chain form. The answer for the first question, the first part, is substituted in the second part, and the answer for the second part is substituted in the third part. The answer for the fourth part is substituted in the fourth question. Clear? So likewise, you should be very careful. If you did any mistake in any one of the parts, then it will be wrong. The answer will be wrong for you. So you should be very careful. So while you find the answer for part A, B, C, and D, please substitute the value correctly in the formula. Then only the answer for each and every sections will be correct. Clear? That's it. Thank you.